everyone should have the notes out as well as a calculator. If you don't have a calculator, please stand up and grab a calculator at this time. You need to know how to do these skills.
Should I look at my calculator from space?
I would. This one's fine. You're going to use this one. That. So here's what the challenge is talking about. What is the first thing you should always do whenever we're doing a section from this? We already have a picture. What should I always put at the top of my paper for this unit?
SOHCAHTOA.
SOHCAHTOA. So that's the first thing I'm going to do. I'm going to top of my paper, put that
How do you spell that?
SOHCAHTOA. Phonetically, how we sound. That's what I went with it.
Yeah.
So Olivia is in a lighthouse on a cliff. She observes two sailboats due east of the lighthouse. The angles of the depression to the two boats are 33 degrees and 57 degrees. You guys learned about angle of elevation and depression yesterday. You guys should be pros in it. We want to find the distance between two sailboats to the nearest foot. Cool thing about this little story here, you guys know what the Titanic is, right?
Yep.
And some of you guys weren't around for when Leonardo DiCaprio was in the Titanic. Actually, none of you guys were born.
I was.
Were you born in 97? Then you were not. Alright, but anyways, this is actually, they did some similar math to this to find the Titanic. They had an estimate of where they thought the Titanic was, and they did some math like this, some trigonometry, and they found its whereabouts using very similar math to what we're doing right now. You guys can imagine doing the same thing. Imagine that this, where the cliff is the top of the water, and the bottom down here being the bottom of the water. They did the same kind of math to kind of triangulate and figure out where it was. So it's pretty cool they were doing some of that same stuff. That's what happened. They did. They were using math. They said, all right, we know it went down here, so if it's going down, falling at an angle, where would it land at? And they kind of did the same thing, estimated where it was at. And they kind of used the same math to figure out where it was at. And and then all the other parts would fall at the same time, how far away they are from one another. So, really what we're doing, this looks very confusing. I understand. There's numbers, there's letters, there's sailboats, everything there. Just take it, break it apart. Ultimately, this entire unit, we are making right triangles. And we're solving for unknown pieces in right triangles. Well, if you look here, I want to figure out the distance between red sailboat and green sailboat. But if you think about it, break it down where it's a little more workable. I really have two triangles. I have this triangle right here that's dealing with the red sailboat. And then I have the triangle, the larger one, dealing with the green sailboat. You guys see those two triangles that we're working with? All we're going to do is do what we've been doing. We're going to find that missing piece of the one triangle. Then we're going to find the missing piece of the other triangle and see if we can figure out that distance. And we will. Some of you have a hard time visualizing this. My line's a little sloppy because the middle of the board is messed up for some weird reason right there. But here's what I'm going to do. I'm going to solve for the little triangle first. I'm going to draw it over here so I can visualize it a little bit better. So just so I can see what's going on here. I know it's a right angle. Let's go on through here. Now, let's see what we know. So you see the green triangle, I just pulled it, drug it over here. I want to know how tall it is from the water to the very top of that tower. Can someone tell me how far it is to the bottom? Gary, how tall is it from the water to the top of the tower?
195 feet.
It is 195 feet because you have to do the cliff plus the tower. So I know this is 195 feet up in the air. I want to figure out how far the boat is away from the shoreline. I don't know what that is. I'm going to call it X. That's the piece we're missing for. We need one more piece because we always need three pieces to solve these. We've got two sides, either we need an angle. That's what we need. So when I look up here, I'm looking at the green one. You guys learned about things about angles of elevation and depression. They're all based on this line of sight up here. Which one of these angles is touching the green one, the 33 or the 57?
57.
The 57 is. And hopefully you learned yesterday when we're talking about this, these have a special relationship because we have these parallel lines right here from the ocean or the water and that. So if I know that this is my angle of depression, what do we call this angle up here where I'm looking up? Very close. Angle of, like think about where you're going, you push a little elevation. These things are really alternate to your angles, so I know their values will be the same. So this is 57 up here, therefore this guy down here is 57 degrees. And again, this is what we want. We want two sides, we want an angle, or however it is, we need three pieces. And we're going to do exactly what we've been doing in the past. So let's solve. We have the SOHCAHTOA, we can set it up. Always start at the angle that you're given. I'm going to start with 57. Let's label our sides now. Going across, you know me, the OPP. Across from that angle. The next one's over here is the right angle. Points over there, shows you where it is. We call that the HYP. And therefore, the last one, if it's not opposite or hypotenuse, has to be adjacent. Again, we do the adjacent last because it's kind of tough to recognize right off the bat. It's one of the harder ones to see. Now we ask yourself, what pieces do I have? Do I have hypotenuse, opposite, or adjacent? I have to have two of the three. So what two do I have? Opposite and adjacent. Good. That's going to help me determine, based on my SOHCAHTOA at the top of the page, which of those trigs to use, either sine, cosine, or tangent. So which one deals with opposite, and you guys said adjacent? Tangent. So I'm going to do tangent. So I'm going to say tangent. The thing that always goes after tangent is the angle. Basically the angle you started at. What angle did we start at? 57. So tangent on my angle of 57 is equal to that ratio. Now if you're at SOHCAHTOA, it's opposite over adjacent. Opposite value being 195. Adjacent value being x. Now, x is going to be in three locations. Either it's going to be the angle, it's going to be up top, or down low. This case is down low. X down low, we should switch a row. So all I do is replace the x in that tan 57. So when I rewrite it, it is x equals 195 over tan 57. I want everyone to try this out. This will tell me what the distance of the boat is to the shore. If you have the graphing calculator, it's real easy to do 195 divided by tan 57. If you have a borrowed calculator, which many of you do, you have to do 195 divided by 57 tan, enter.
Well, we could have put divided by enter tan.
That's whatever it is. You have to figure it out. 195 divided by 57,
Enter.
and there'll be a decimal, tan, and then enter. One enter after that. And when I do so, I get this one. Megan, what did you get when you get this in? 126. If you did not get 126, that's approximately, you rounded. 126.6, please raise your hand. We can help you get set up. Especially if you're borrowing our calculators. You need to have to use those when test time rolls around. Please work backwards. 195 divided by 57 tan, enter.
Alright, I'm done on this.
Tan, enter.
Wait, this ain't coming.
Alright, now we have that. That is finding the little triangle. That's finding sailboat A, the red sailboat. We want to find now the purple one. I'm going to draw that triangle over here as well. I'm just pulling it out to draw it. Again, I realize some of you guys can do it without separating it, but I'm just visually showing what's going on. The nice thing about this is these triangles are very similar to one another. They're oriented the same way. So the lighthouse is still the same exact height. It's 195 feet up in the air. I want to know how far sailboat B is away from the shore, so I call that X. There's only one thing that's going to change now with the purple triangle. What's going to change in this? The angle of depression. So now what angle of depression is hitting this purple one? 33. So now I know if this guy's 33 up here, well, alternate tier tells me that this will be 33 down there as well. So this is 33 degrees. And the process starts again. The nice thing is, with this, you know, this is going to be in a similar place, that they're not similar triangles, but they're similar setup, that I know the matchup will be very similar. There's my angle, going across, the OPP, across from the right angle, CHYP, and down here has to be the ADJ. Well, if you notice, I'm still using the opposite and adjacent. Okay. Opposite and adjacent, if you look at the top, refers to my tangent. So my setup is going to be really the same with one difference. What is the angle I started with now? 33. That's the only thing that changes for this problem. Is equal to 195 over x. X down low, switch a row. So that x and that tan, they switch. X equals 195 divided by tan 33. This will not be the same answer because now we're using a different angle. So again, type in your calculator, you have it, tan, or do 195 divided by 33 tan, and you will get this number. Graphers, you can do it? Yes? 300.3.
I'm not getting this.
I'll help you out in a second. 300.3. Probably hit enter too many times or equal too many times. Now, so that's great. I know that that boat is that 300 feet away from the shore. I know this one's 126 feet away from the shore. How do I know how far apart they are from one another? Who has an idea of what we can do? Gary. Subtraction. You're exactly right. So I'm going to take boat A, or the bigger boat, where the one's furthest away, the 300.3. I'm going to minus the 126.6, and I want to round to the nearest foot, the whole foot. So when I do that, about how far is this boat away from one another? Give someone else a shot here. Thank you, brother. Alex, what do you got? 174 feet away from one another. But it says round to the nearest foot. So I'm going 174.
Oh.
Let's be careful. I'm trying to say equals on those. All right. Questions on those? Again, if you can do this one, this is probably one of the harder ones that you have to do. That's a great one because I guarantee you will see one very similar to this down the road. All right. So this one.